Space science is so important for understanding our place in the universe, but also understanding how our Earth works. Without space technology, we would have no GPS in our cars and our phones, we wouldn't have satellite communications, and we wouldn't have the Earth observation data that allows us to make, for example, accurate weather forecasts every day. CSIRO is the Commonwealth Scientific and Industrial Research Organisation, and we're Australia's largest research organisation. CSIRO owns and operates all of the radio astronomy facilities on behalf of Australia. These are collectively known as the Australia Telescope National Facility. The ATNF offers astronomers a unique view of the Southern Hemisphere sky, and it's available for use by Australian and international astronomers worldwide. CSIRO has a 50-year partnership with NASA, particularly with regard to the operation of the Canberra Deep Space Communication Complex.
NASA's Deep Space Network is a set of stations around the world at Goldstone, Canberra and Madrid. By coming together as a network, they are able to now look at the entire solar system and chart every robotic space mission around every planet in the solar system. Canberra Deep Space Communication Complex has 3 34-metre antennas and one 70-metre antenna. The 70-metre antenna is the largest antenna in the Southern Hemisphere. This place is extremely special to the people that work here. Their roles are so vital to make sure we carry the signals from deep space. We carry them safely, we carry them with consistency, and we don't drop a signal, and they do this perfectly. They make history every day. The work we do here is playing a key part in the exploration of the solar system. The images we're getting back from Pluto, the images we'll get back from the Cassini end of mission, the images that we get back from the Mars rovers tell us something about what composes this solar system, about where Earth and us sit in this big picture of the solar system.
Astronomy and space science give us two viewpoints for viewing and understanding our universe, looking up and out at the solar system and the universe, but also looking down at Earth from space. The data we receive from Earth observation satellites enables us to learn and manage things like weather and climate, environmental management, emergency response, and resources management.
We downlink the data from a number of satellites. Most of them are owned and operated by a number of other countries, but we have access to about 120 satellites, about 250 sensors on these satellites. We manage about 1 petabyte of satellite data together with our colleagues from Geoscience Australia. We've developed with them what we call the data cube technology, which allows us to pre-process a lot of this data and organize it and clean it up very well so that researchers but also government agencies can look at changes across the landscape for a single part of the country in terms of agricultural production or flooding or coastal change and things like that. GEOGLAM stands for Global Earth Observation Agricultural Monitoring System. GEOGLAM was called for by G20 about 6 years ago to use a lot more satellite data to monitor crop production worldwide. In Australia, we said that we needed also to monitor livestock and beef production. And therefore, we've developed GEOGLAM RAPP. RAPP stands for Rangelands and Pasture Productivity. We're helping create the necessary decision-making information and the tools to monitor how we're managing remaining resource and lands that provide this protein and food.
CSIRO has a very broad range of capabilities that can potentially be applied to space activities. They include advanced communications technologies, sensor technologies and robotics.
A hexapod is literally something with 6 feet. What they do is they walk more gently over the Earth than wheeled or tracked robots do. They're also more agile, so they can step over things, they can duck under things and turn themselves in circles without skidding. Hexapods can go where no man has gone, where no man should go, and in the case of the smaller ones, where no man will fit. If you're on a planetary body or something similar, a hexapod can walk over rock piles and up much steeper gradients, and thus it can carry its sensor payloads to places that would otherwise be inaccessible. SLAM is simultaneous localization and mapping. It works similarly to how humans work out where they are and make a map in their mind of the room they're in, for example. Robots for exploration are only useful when they're carrying sensors, so cameras, laser scanners. With our 3D SLAM technology, they know exactly where they've been, so they can provide you with a map of where they walked. They don't rely on memory, they keep a log of everywhere they went. The hexapods are a massive step forward in taking instruments to observe the universe in which we live.
CSIRO aims to harness its innovative culture, its technical capabilities, its international relationships to support the Australian space sector and to develop a powerful innovation pipeline for the Australian space industry.